Automotive OEMs define their own in-house communication specifications based on ISO standards to verify communication for individual vehicle ECUs. Using these specifications, they require Tier 1 suppliers and partners to validate communication conformance. Specifically, CAN-FD physical layer verification based on ISO 16845 and ISO 11898 is typically performed in a very manual way. Test engineers have to build the test circuits for each test case and repeatedly execute simple, specification-driven checks by hand. This conventional approach has two clear drawbacks. First, different measurement criteria from engineer to engineer easily lead to human error. Second, the repetitive nature of the work means that a single test campaign can take roughly 2 weeks to complete. These issues can be addressed very effectively with the ScopeAnalyzer. The test engineer simply connects the DUT to the oscilloscope, and then uses the ScopeAnalyzer to control the scope. On top of that, the ScopeAnalyzer offers a wide range of additional features, including automated CAN-FD physical layer verification based on its own dedicated algorithms. Here are a few example use cases. First, in the process of validating bit timing by repeatedly measuring the rising and falling edges of the CAN-FD waveform, the ScopeAnalyzer can reduce the T-state time from about 5 days of manual work down to approximately 3 minutes. Second, for measurements of the delay between TXD and RXD signals at the MCU and transceiver interface in the CAN bus lines, engineers can easily configure these delay calculations using the math functions, which again shortens the overall test time. Third, by applying the built-in algorithms during measurement, the ScopeAnalyzer provides a consistent reference for dominant and recessive voltage levels and measures them in a uniform way. The main building blocks of the ScopeAnalyzer solution are as follows. Here you can see a demo video for use case 1. For each test, the engineer enters the required limits from the specification, then starts the test so that the ScopeAnalyzer automatically controls the oscilloscope and performs waveform verification. All waveform captures taken during automated scope control are stored in an image folder like the one shown above, and these images can later be used as evidence when issuing formal test reports. In addition, the conformance results for each ECU can be exported as CSV files.